Hello, everyone, and welcome to our presentation. We are Team 3994. It's an honor to have the opportunity to participate in this year's United Nations Big Data Hackathon. Please let me introduce myself first. My name is Lingyang Xie, and you can also call me Damon. I'm an undergraduate student from the University of California, San Diego, majoring in political science. We have three other talented and excellent teammates here. They are Luna, Emily, and William. Thanks to their hard work for those 4 days, we can finally present our work and solutions to you. So let's dive right in. So our presentation topic is improving agriculture productivity and reducing food insecurity in the least developed countries. We choose to focus on the third point of this year's hackathon topic and aims to introduce a solution to the rise of food and energy price. However, before we present our AI-based solution, we think it's very necessary to give you a brief overview of what's happening around the world. So we want to give you a brief overview of the current situation of inflation. According to IMF's World Economy Outlook on October 2022, the world economy remains historically fragile. The organization argued that we are at the edge of towards recession. Here you can see we have an inflation rate of 9.1% on the world average in 2022. The inflation rate is also at its all-time high from the last 5 years. And global medias are becoming worried about the situation. Here are two quotations from two notable media sources, Financial Times and New York Times. They all warned us that we are at a greatest risk of the rise of inflation. Yes, we must admit that the situation is far worse than we expected, and we are at an edge of economic collapse and depression that may be far worse than 2008. However, most notable media mainly cover about the situation of these developed countries. So one question comes to the mind of our team members. What was the situation of those least developed countries and those developing countries if these developed countries are suffering such far? And here you can see another chart made by our team members based on the global inflation rate based on IMF data. We calculated the average of 46 least developed countries based on United Nations data, and we compare their inflation rate with the global rate. The blue line here represents the average of 46 least developed countries, and we found that their situation are far worse than we expected. They have 5% higher inflation rate than the world average, and 33 out of 46 least developed countries are in Africa. This is United Nations data. So our solution will focus on the least developed countries in Africa. And also, this is the reason why we developed this world food inflation heat map. We built this information based on the International Labour Organization's data. We use different colors to represent different thresholds, and you can see those purple countries, they are experience the highest inflation rate, greater than 30%. And if we look at a broader perspective, those purple and light blue countries, meaning those experience the top and second inflation rate countries, are mainly located in Africa. On the other slide, we also use a histogram to help you better understand their situations. The 5 out of top 10 countries experience the highest CPI on food are in Africa. This is corresponding to what we analysis before in the previous slide, that these least developed countries are suffering most from the highest inflation rate. According to the Global Report on Food Crisis 2022 Mid-Year Update, At least 1 in 5 Africans goes to bed hungry, and an estimated of 140 million people in Africa face food insecurity. So we know that food prices are rising sharply around the world. So we talked about the food security issues in the previous slide, but for those who are new to the topic, you may ask, what is food security? Here, we use the definition of United States Department of Agriculture's definition of food security. It is defined as a household-level economic and social condition of limited or uncertain access to adequate food. And rising food costs could mean falling into food security, reported by CNN Business. So, but how can we improve food security? This is a question. And here we want to remind you a very simple economic concept, the supply and demand curve. So in order to lower the price of the food, in the ideal economic context, we can make two options. The option one is increase the supply, and option two is decrease the demand. But in the real world context, we can't decrease the demand of food. The only solution for us to do is increase the supply, and we focus on solution to increasing agriculture productivity. To increase agricultural productivity, we must know the agriculture situation in Africa. According to McKinsey's market report on Africa's agriculture market, so 60% are smallholder farmers and 23% of their GDP comes from agriculture. And our solution to improve the agricultural productivity are also in line with United Nations Sustainable Development Goals. So you can see goals number 1 and number 2. We highlight the keyword that connects our solution to the United Nations Sustainable Development Goals. And here we will present you the ARC-AI, our data-driven solution to increase agriculture productivity. So this is ARC-AI. We developed the image based on the data from NASA satellite and ground image on crop and soil. We convert the image in cropland data and soil and crop photo, and we use data analysis and machine learning approach to train our AI system. And we also combine the data of weather, geospatial, soil, and use the model of AI to get a solution. Finally, we can get yield forecast and database decision of the ARC-AI. Also, let me dive in for how our solution can help achieve the United Nations Development Goals. How can we help those in need? So, the yield forecast and database solutions can enhance income and other entitlement to food by increasing the food productivity. We can tell the farmers which crop is most suitable for them and increase their effectiveness. And we can also improving rural food protection, especially by small-scale farmers, especially give them an alert system of disease to make them aware that their crop are under a severe condition to make them better adjust to the situation. So this in line with United Nations Sustainable Development Goals. So we have two main functions of our ARC-AI. The first one is crop recommendation. It's a very simple one. You can upload the image, and we use AI analysis to recommend a crop for you. And we use data sources from Lacuna Fund. So the data sites are over 28,000 images across 8 counties in Kenya. For presenting the technical detail, so let me introduce our technical engineer, Luna. She is a master's student from the University of California, San Diego, and she will introduce you the technical detail of the computer vision data cleaning, and artificial intelligence.
Hi, my name is Luna, and let me introduce the models we're using. We trained all of our models locally in Jupyter Notebook. And for this part of the problem, crop recommendation, starting with the data processing, we mainly use two things, a pre-trained VGG19 model and principal component analysis. This is an image of the VGG model we're using. We mainly use this for feature extracting. VGG model, let me give you some background, is a recent popular convolutional neural network model that was proposed in 2013. And the most striking thing about VGG model over the other CNN models is that it has a very small kernel or filter that's uniform across all of the layers. It's called VGG19 because it has 19 trainable layers. And after we extracted all the image features, we save the data in n times 256 matrix. And then we use the principal component analysis to do a dimension reduction to speed up our processing time and still keep important information about the image. So this is the part we do the PCA reduction. And this is a picture of the principal component analysis. And this is the code we wrote to extract the image using the VGG model. After we do the data processing, we created three recommendation models: linear regression, support vector machines, and naive Bayes to do recommendation for the users on the crops. We used 80% of the data for training and 20% of the data for testing. After fitting and predictions, we also evaluate our models with various metrics such as accuracy, recall, and F1 scores. Linear regression model turns out to have the poorest performance with an accuracy of around 0.18. SVM and naive Bayes have pretty much the same performance, both around 0.9. We choose in the end to use SVM in our website, which our teammates will do a demo later. So this is a picture. These are the pictures of the three models we're using and the code where we wrote to train and fit and predict the data. So that's the end of the introduction about crop recommendation models.
Thanks for Luna's introduction. So our second main function of ArcAI is crop disease detection and warning system. So it seems like the crop recommendation function. You can simply upload an image of a plant, and we will go through the ArcAI analysis, and you'll get the detected crop disease. Or if your crop is in a good condition, it will show you that you are excellent. So for more technical detail, we will introduce Luna again for deep explanation.
Now let me introduce you about the disease detection models we're using. So we tried two models mainly. The first one is AlexNet. You can see a picture here. It's a famous convolutional neural network that contains 8 layers. We built one ourselves, as you can see in this picture, and we trained our data using this model. However, after we did the prediction on the test data, the performance we found out is pretty low, around 0.16 accuracy. This could be many problems I think one of the main reasons we have this low performance is we have a small size of data set. We only have 2 crop type and each have a few disease, only a few disease, and each disease has less than 1,000 pictures. So we tried another model called, we tried to use the same model as we used in the crop recommendation, the VGG model, to extract the features of the image and using SVM to do image classification. So this is the picture of VGG neural network and the code we use to do feature extracting. After we finished the process, we found out there is a slight increase of the performance around 0.33, which is rather low, but still improvement on the previous model. So after we finish the image processing, we also used SVM for image classification. And finally, we print out, this is a picture of the code, and finally we do the predictions and then show the classification report for this model. And that's the end of the introduction about disease detection.
Thanks for Luna's explanation. So sounds great. We think you may not feel vivid or clear enough just looking at our PowerPoint presentation. So to let you deeply understand how our AI system works, we want to show you our demo of a whole set of websites incorporate our AI. So next, please welcome William, and he will demonstrate you the demo.
Hi, this is William. And now let me show you our project website. It includes the front end and back end. Front end is made by React library, and back end is created by Python Flex framework. We use the Jupyter notebook to create data models. So here we have 4 tabs. This is our homepage. The second one is a global inflation heat map. For example, this is the data of the Canada. This is the data of United States. And next one is the crop recommendation. This tab is for data input and output. You can upload your image of the land, and it will display the most suitable crop to grow on this land. As you can see, for the posted image, the best choice is mice. When the user clicks the upload button, it will send HTTP post request to corresponding backend endpoint. In the endpoint, we will import the model we trained to predict the result. After we predict the result, we will send the result back to front end in JSON format. And then the front end will catch this JSON data in the HTTP response to display the result. For the last page, the model has a similar function as the previous one. For this one, you upload the leaf image. And it will tell you what kind of disease the crop has. That's it. Thank you.
Thanks for William's demonstration. So although the whole system looks good so far, we were well aware that the results developed in just 4 days still face many difficulties and challenges, such as the amount of data is not enough, and AI training time is not enough too. So our ARC AI still has a lot of room for optimization and improvement, and it also needs to continue to be integrated with the local situation in Africa and together hardware and monitoring system to form a whole set of agriculture graphical sensoring solutions. And here's our future development for the ARC AI system. So some hard functions like agricultural robots, real-time surveillance, and mechanized agriculture, so they can combine with the ArcAI, our data-driven solutions, to create a more efficient and effective agriculture in Africa. So changing the world never comes in just a few days, but we want to make it happen with creative ideas. United Nations Big Data Hackathon is an excellent opportunity for us. So thanks for those who organize the event. Thank you for your hard work that can truly make a difference. We also want to thank United Nations to provide the opportunity for us to use. As His Excellency United Nations Secretary General Antonio Guterres said, the best hope to address challenges is with the new generations. We hope our solutions will be helpful and inspiring for everyone, especially for our peers. So thanks for watching. Stay safe. Thank you.